Okay, here we go again. I don't know what I got going on here. June 15th, 2022, 7:37 p.m. in the U.S. And it's that same time a.m. in Philippines. What we're going to look at today is a new kind of stairs. Might be new to everybody, but sure enough new to me. This is for the second, going from the mezzanine deck up to the upper deck. You call them like the second story stairs for Villa Cecilia. In that slab that is that thing, this curve right here, and around there, and then a straight line, and then around this curve. That's the cutout in the floor, so when you climb the stairs, there's someplace for you to be. So you haven't got to keep just bending over lower and lower. Anyway, this rounded end, the inner and outer circle over to that. The rest of this is all concrete, and this centerpiece is concrete. In that, when that slab was poured, we have holes. This 3/4 inch PVC conduit is bigger on this drawing, but it really is 3/4 PVC. And those are around at a constant radius off of a center point. And there's another set of them here around an inner radius. The intent, when we poured the slab, was we were going to put like inch or inch and a quarter pipe between the bottom of the upper deck and the top of the lower deck. Sort of like a cage around here, so she couldn't fall out of the side of the stairs and go clear to the next level down. This is not a very tall section through here. It's about 8'6" to 8'7". I'm not exactly sure what it is. It's not the lower deck is 10 feet 1 5/32 as floor to ceiling height, but this is hasn't got the beam on top of the wall. It's got the beam integral to the wall. They're both monolithically poured, but one of them is it was a full height 8-foot form, and then the beam form mounted to the top of that, and the other one we had a rectangular form, and we put pieces on the inside of it like boxes that made the wall thinner than the columns and the top and bottom beams, one on either side, and they have like 45-degree edges on them where they come right out of the concrete when you pull it off. Anyway, I've done one trial on the run on designing the stairs, and it goes from the red line to the red line. That's 34 and a little less than 3/4 of stair tread width. I don't know what the code is, but that looked like a place to start, because that's the size of the hole. I wouldn't want them any smaller than the size of the hole. And I'm thinking now that I can run these rods from the top deck down through. If these stair treads were longer, through one tread, and then they got the toe kick, so it would go through the next the other edge of the following tread. So it would go through. You'd have one going through here. And that would go through the upper step and the back of the lower step, and then next one back would be the front of the uphill step and the back of the lower step. Same thing on the inside. And I think I'm going to draw them up again with that. But for right now, what we got the drawing is for this, and it'll look pretty similar. The other way. Okay. Scoot over. There you go. The bottom tread is a box. This it won't have this. We're looking at the forms. This won't have a bottom in it because that will be the floor down below. It'll just be a perimeter form on that. Let's see if we can get this word. I should have changed it. Oh, there, that's starting to look a little better. Everybody knows what the top of a set of stairs looks like. It's the treads. But I think I got a chance for an architectural feature with the bottom of the stairs. And if you've seen any of the older videos, the bottom of the stairwell room, the first floor to second floor stairs, it's got a feature shape on it. Or it's not just a smooth, flat curve. It's got the side walls on it. It's a sort of, integral handrail, full height handrail. But and that is just around smooth curves. But the bottom has got a feature shape. This is probably not a good thing to show it with because it's the forms, and there's a lot of stuff hanging out like this ear. To attach these two things will be a piece of 2x2 that wood they get from Malaysia. So it has to have a way you can screw into that. It'll be screwed from the inside to the 2x2. So the front demounts, and the bottom, all these sides hanging down here below the below this piece with the V shape in it. Here, you see them over here, here. That'll also have pieces of 2x2. And then under here, there'll be another couple 2 pieces. So it'll screw all together. All the screws come out from the outside, from the bottom. And this goes on around. We're still looking at the bottom. The forms on the helical stairs were a nightmare. My 2 best guys, and another guy that he was really good too. They spent 2.5 weeks every day on those forms. Poured them in 3 hours, but it took 2.5 weeks to do the forms. Anyway, the top. This surface here will be the top of the next floor. The next floor is always your top step. It's your top tread. It's just wide. It goes the whole diameter of the room. I'm amazed at the way this 3D can spin all that stuff around. And this is not a super fast computer here. I think it's 1.8 gigahertz. There's only 2 cores. My other computers are all like 4 core. Well, we got to find one here that's the stair treads, not. Well, I can't see it there. Let's find it here. I think that's treads. Yeah. So that's not so hard to find. There's 2 iterations of this too. It's upside down. Well, you can see the bottom though. The bottom one being that it's flat on the bottom. And these other ones, this blue form here, that's tilted up to make it thinner here. I got another picture of it with that, all of them with this height, and I thought it looked kind of chunky, so it just wasn't visually right. And I could make them a lot thinner. the stairs that you climb, that way you would see it. Start to look more like stairs? Does to me. Oh, this is 274 and 0.286 degrees of rotation, and the rise is 6.93 inches. The tread's 16 inches wide on this end and 7 inches wide on the short end, which means you could probably come down the inside. The 7 inches is a nose to nose run. There's a 2-inch toe kick, so you actually have 9 inches if you want to climb up that side. 9.6 or 9.7 inches is what it actually is. But when you're coming down, your heel has to clear the step you're going on, so you don't have the toe kick to come down. That's why spiral staircases are so ugly to come down. The tread's only like 3 or 4 inches wide on the inside end of it. So they're totally useless over there. And they only have the sweet spot on the right. Our helical stairs, the treads are wider than this, but they have about the same dimensions. Anyway, okay,